there, I'm Sridhar Rajgopal, the founder of Upbeat Labs and the creator of Dr. Wattson Energy Monitoring Board and ProtoStax Enclosures. In this project, I have created a self-contained and portable energy monitoring and analysis device with an integrated web app. Let's take a look at it. This is the device here. It has a power input and an output here, outlet here. So it measures the energy parameters of any device that is connected, i.e. plugged in, like current, voltage, line frequency, power factor, active, reactive, apparent power, and so on. It displays the current metrics on an OLED screen and also logs it to a time series database. It exposes the current metrics and the historical data through a web app. It is built with a Dr. Wattson energy monitoring board, a Raspberry Pi, I'm using the Pi 4 here, a custom OLED screen that also has connectors for the Dr. Wattson to make the wiring easy, and the whole project is inside ProtoStax enclosures to make it portable and usable. The Raspberry Pi is running a Python Flask based app that queries Dr. Wattson every second or so. It displays the information on the OLED screen and also writes the data to an InfluxDB time series database that is running on the Pi. The app also presents a client web interface using HTML, CSS, and JavaScript. So you can see the current metrics on a dashboard and also view historical data that is queried from the database and displayed through charts. Here I have a browser that is pointed at the Raspberry Pi through port 5000, which is where I'm running the web app. And that presents this, this home page, which is a dashboard. So you can see all the current metrics here. Current RMS, voltage RMS, line frequency, power factor. This shows any events of interest that have occurred. There are four main events like overpower, overcurrent, voltage sag, and voltage surge. And for each of these, you can define what the triggering condition is. So for example, overcurrent would happen if it's the current consumption is greater than 0.18 amps. And these are limits that I have chosen to demonstrate. An overpower condition happens when the power consumption is greater than 16 watts. And here it shows which quadrant it is in the power quadrant. So quadrant 1 is, for example, it's you're consuming power and it's inductive in nature. Quadrant 2 is you're generating power and it's inductive in nature, or you're generating power, it's capacitive in nature, or you're consuming power and it's capacitive in nature. Then you have active power, reactive power, apparent power, and also it displays the amount of energy that you have consumed for the day. So at midnight every night it resets the stats. So this shows how much has been consumed in watt hours since midnight. So for each of these metrics you can also click on it and it brings up a chart that shows the last 5 minutes of activity. So for most of these you can click on them and get the metric charts. You don't get it for the event condition or the power quadrant. All right, now let's go ahead and I'm going to turn on the TV here. So you can see suddenly there is a spike in the current consumption. So once the cable box was turned on, you can see, and an image is presented on the screen. You can see that the current has jumped up to about 1.5 amps. And the power factor has also shot up to close to 1, which is good. So you can see the ramping up of the current. And here you can see that there are two triggering event conditions that have occurred. Because the current is greater than 0.18 amps, the overcurrent condition is triggered, and the over power condition is also triggered because the power consumption is greater than 16 watts. You can see it's consuming about 100 watts of power. And on the device itself, you see the red LED light up to show that an event condition has been triggered. So now you can also go and click on the metric charts link to bring up a chart that can show the various parameters here. So you can view multiple parameters on a single chart. So by default, it shows only the current, but you can enable other metrics also, such as voltage or active energy import and active energy or reactive energy import. And you can also select the date range. So by default, it shows the last 5 minutes of activity, but I can go back and look as far back as 24 hours. Of course, this is an open source project, so you are quite welcome to go and change the intervals and look back in time for a longer period of time. So here you can see the parts where the active energy import is has a slope, shows that's where consumption is happening, and then when it's flat, it's being inactive. So basically, looking at this chart, you get an idea of when the TV has been running, and a similar thing can be figured out by looking at the current chart. So all the parts where the current shows a spike and stays up are periods of activity where the TV has been on. So you can see that the TV was on at around 10:24 a.m. till about 11:14 a.m. and then again from 1:54 till about 3:14, and now it's again been turned on at around 8:45 when I'm talking to you right now. That's when I just turned on the TV to demonstrate. And I could go back to last 24 hours and see what the patterns were. And this screen automatically refreshes, and the refresh interval is also varies depending on the amount of data that is being pulled in. So if it's the last 24 hours of data, you don't need to pull in new data too often. So it refreshes only every 60 seconds. But whereas if I go to the 5-minute range, it refreshes every 5 seconds. And another feature here is that you can select and rescale the y-axis. So right now it's doing an automatic scaling based on the data, but you can choose to say go between 0 and say 2 amps. And if you delete those, it will go back to an automatic scaling. There is also a help page that as of now is still empty, but I'm working on filling that out. And then the docs link takes you to the website to find help and instruction manuals for Dr. Wattson and for the enclosure. All right. And let me go ahead and turn off the TV. And you'll find that the overpower and overcurrent conditions automatically go away as the power consumption drops and the current drops. So when the TV is on, it's in quadrant 1, so it's consuming energy and it's inductive in nature, and when the current consumption is minimal, the power quadrant doesn't really matter, so it is removed. I used this project to get information on the TV watching habits in our household, when we watched, for how long. Knowing the electricity rates, such as peak rates and off-peak rates, it is also possible to calculate the cost on a daily basis. If you're a small business running a piece of equipment, for instance, you can get similar metrics on your equipment: how long it has been running, how much current or power it is consuming, and how much does it cost to run. You could use this information to better estimate your product costs, for instance. What type of load are you going to analyze? What type of solutions are you going to build using this? Let us know in the comments below. The entire project with instructions and source code is available on our website, on our project hub, and on GitHub. So please check it out. If you like this content, please hit the like button and subscribe to us to get notified when we post other similar projects in the future. Thank you.